Good morning and welcome to 4.3 Ambiguous Case of the Sine Law. Let's begin. For the opening question, what I want us to think about is if given triangle ABC, and so let's just draw this quickly. If A is 53 degrees, C is 15, and A is, A is 12 and C is 15, can you find two different values for angle C? And what would those two triangles look like? So if we were to set this up as a sine law, I'd go, we're trying to find angle C, sine 53 over 12 equals sine of C over 15. If I were to cross multiply and divide, I'd go 15 times sine 53 divided by 12, second function sine, answer. And I would get C as 86.6. But now that we know with sine, right, it can be the angle, but that's also equal to sine of 180 minus the angle. So C could also be 93.3. So in this case, there's two possible angles for C, which could make two possible triangles. And that's what the ambiguous case is all about. It's about examining when there could be more than one possible triangle. We're going to get into that here piece by piece. So the ambiguous case defined is a situation in which 0, 1, or 2 triangles can be drawn given the available information. The ambiguous case may only occur when the information is side-side angle or angle side-side. So you can see, depending on how you looked at it, side, side, angle, or if you read it backwards, angle, side, side. Whenever you have side, side, angle, or angle, side, side, it's an ambiguous case. So you're going to have to examine the information to see if there is 0, 1, or 2 possible triangles. Okay, and we're going to get into each of those scenarios here in a moment. Okay. All right, I'm going to click ahead. In the interest of time, you can come back to this afterwards if you need to. Okay, I know there's a lot here. If you don't want to write it down right now, you could always take a picture. You could watch the video again after. But I understand there's a lot to go through here. So step one to examine is if the given angle is obtuse. Okay? If the given angle is obtuse, which of course means the angle is greater than 90 degrees, right? If the given angle in a side-side angle triangle is obtuse, there are two possible outcomes. So here are your two outcomes if the angle is obtuse, right? We can see right here, we've got an obtuse angle. Case number one. The given angle is obtuse and the side opposite that angle is greater than the other given side. So remember, this is a side-side angle triangle, so they're giving us two sides and one angle. So if side length A is greater than B, there is one possible triangle. Okay? If the side length opposite the angle, if that's greater than B, then there's one possible triangle. It would look something like that, right? The triangle would go here with an obtuse angle, Now side A is longer than side B, so we can reach down and we can have one possible triangle. Obtuse case number 2 says that the given angle is obtuse and the side opposite that angle is less than or equal to the other given side. If that happens, there are 0 possible triangles. So once again, here we've got a side angle given. This angle here is obtuse. If side length A, which is opposite of angle A, obviously, if this is less than B with an obtuse angle, there's no way to make a triangle. As you can see, with side length A being less than B, it can't connect down here. There's nowhere to draw side length A to make a triangle. So if you have a side angle triangle with an obtuse angle, and A is less than or equal to B, there's 0 possible triangles. So the type of question you would get on something like this, like on a test, they might say angle A is 102 degrees, side length B is 24, side length A is 21. And it'll say how many triangles, 0, 1, or 2. It could be a multiple choice question, okay? And then what you would do in your checklist in your head is you'd say, okay, the angle's obtuse, side length A, which is opposite of angle A, it's less than B, so that means there's 0 triangles. If I changed it and I said this was 25 and B was 24, then you'd say, hey, the angle's obtuse, side length A is greater than B, that means there's 1 triangle. That's the first step. When the angle's acute, which is what's coming up, it changes slightly, but for obtuse, you have 2 possibilities. A is greater than B, and it makes 1 triangle, or A is less than or equal to B, and that makes 0 triangles. Okay? And there's a checklist later on that'll help you. Again, here's that example, right? It says the angle A is 114 degrees, side length A is 18, side length B is 12, and asks you how many triangles. Well, you go through the checklist. That's an obtuse angle. Side length A is greater than B. That means there's 1 triangle. Okay? In this question, it didn't ask us to calculate the sides or anything, so we didn't even really have to write any of this down. Question 2, again, obtuse angle. Here, A is 12 and B is 18, so A is less than or equal to B, which means now there is 0 triangles. Okay? So those are the 2 possibilities when the angle is obtuse. Step 2 is if the given angle is acute. Okay? If the given angle is acute, that changes somewhat. Okay? Here there are 4 possible outcomes. Okay? So we'll go through them one at a time. Before you can do anything, you have to find the height of the triangle. You know that this is your acute angle. Right here, let's say it's 41. They're giving you side length B. Let's say this was 7. The first thing you would have to do is find the height of the triangle. Okay? So if we found the height of this one I wrote down here, the height's going to be straight up and down, obviously, right? So I could go sine of 41, because it's a 90-degree triangle, equals h over 7. Sine 41 times 7. H would be 4.59, would be our height. Okay? So this is our height for our little example we just made here. If the opposite side, which would be side length A, if the opposite side is equal to the height, there's one possible triangle. And what does that triangle look like? Well, it looks just like this, right? If the side length A is equal to the height, there's only one possible triangle, and it just looks just like that with a 90-degree angle. That doesn't happen very often, but that's sort of the baseline for it. If the opposite side is equal to the height, there's one triangle. Step 2, if the opposite side, change colors here, if the opposite side is less than the height, there are 0 possible triangles. So if we said that our height was 4.59, and here they gave us that A was 3, that means that there are 0 possible triangles because A is less than the height. There's no way, no matter where you swing this side length A, it can't make a triangle. It doesn't reach the ground. So if side length A, if the opposite side is less than the height, there are 0 possible triangles. Okay? The third possibility is if the opposite side is greater than equal to the other given side, there is one possible triangle. So what that means, let's say that side length B on this diagram here, let's say B was 5 and side length A was 8. If the opposite side is greater than or equal to the other given side, there's one possible triangle. Okay? And it would look something like this, right? Because side A is longer than side B, it's just going to make a big triangle like that, okay? The final possibility, and this is the one that sometimes students have trouble with, if the side opposite the given angle is greater than the height and less than the other given side, there are 2 possible triangles. Once again, if the side opposite the given angle is greater than the height, but less than the other given side, there are 2 possible triangles. So in our case, we said the height was 4.59. Let's say B was 6 and A was 5.5. In this case, there are 2 possible triangles because A could go here, right? It's longer than the height, so it can make one triangle that way, but it's also possible that A could make a second triangle this way instead. So we could have one triangle that looks like this, but we also could have a second triangle that looked like this. And this is why it's called the ambiguous case, because there's 2 possible outcomes. And given the information we've been told, we don't actually know which triangle is possible. So you have to sort of write down both of them. Okay? Now I know that slide has a lot of information and a lot to take in. Once you can see it in action, it hopefully will start to make a little more sense. So it says, given each SSA, side-side angle situation for ABC, determine how many triangles are possible. So we can see all of these triangles have angles of 30, and the B side, the length of B is 12. So the step 1 is to find the height. Find the height. So let's try and find the height of this triangle. This is 30. B is 12. And we're looking to find the height. So sine of 30 equals h over 12. That means the height of this triangle is 6. So step 1 is to find the height of the triangle. Now we can go through the steps. In A, it says A is 4. So A is less than the height, right? If A is less than the height, there are 0 triangles. Okay? Because A is less than the height. In B, it says A is 6. 6 is the height, so A equals H. So there's 1 triangle. It's a right triangle one, and that's because A equals H. In part C, A is 8, the height is 6, so A is greater than the height, right? A is greater than the height, but A is also less than B. So in this case, there are 2 possible triangles. And that's the special case, where A is greater than the height, but A is less than B. In part D, A is greater than B. As soon as A is greater than B, A is greater than B, there's only 1 possible triangle. Okay? Next. And here's those steps. So this is a good one to make sure you come back to. And when you have more time and you can pause the video, this is a good one to add to your notes. It says if you're given angle A, side length A, and side length B, which is a SSA triangle or ASS, step 1, is the angle acute or obtuse? Okay, remember, if it's obtuse, there's only 2 possibilities, where A is greater than B and there's 1 triangle, or A is less than B and there's 0 triangles. That's what you're going to do in step 2, is compare them. In step 3, if it's acute, so step 3 is if acute, you're going to calculate the height. Okay? Once you calculate the height, you can compare A and H. If A is less than H, there's 0 triangles. If A is greater than H, if A equals H, there's 1 triangle. If A is greater than B, there's 1 triangle. And if A is greater than H and less than B, there's 2 possible triangles. Okay? Again, this is a good one to come back to later on. All right, let's do this one here. It says Martina and Carl are part of a team that is studying weather patterns, okay? The team is about to launch a weather balloon to collect data. Martina's rope is 7.8 meters long and makes an angle of 36 degrees with the ground. Carl's rope is 5.9 meters long and, assuming that Martina and Carl form a triangle in a vertical plane with the weather balloon, what is the distance between Martina and Carl to the nearest 10th of a meter? So here's what we've got. Let's start drawing our triangle. Here's the weather balloon up here, okay? Martina's rope, oops, let me draw a better line than that. Martina's rope is 7.8 meters long, and she makes an angle of 36 degrees with the ground, okay? Carl, his rope is 5.9 meters. And we need to figure out the distance, we're trying to find this length right here. What's the distance between where Martina is right here and where is Carl standing and how far between them? So the first thing we're going to do is I can see, step one, acute or obtuse. We can see that the angle is acute, right? So we know we've got an acute angle. So then step two is to find the height. So let's find the height of that water, of that balloon. That's right here. We're looking to find the height. So that's going to be sine of 36 equals h over 7.8. Calculate that quickly. The height is 4.58. Okay? The height is 4.58. Step 3, examine A and B. Well, A is Carl's length. That is 5.9. And B is Martina. She is 7.8. So had Carl been, if 5.9 had been greater than B, then there would have only been one possible triangle. That's not the case, so we have to keep going. So now we examine A and H. Well, A is greater than H, and A is less than B, so this means there's two possible triangles. So now we have to try to draw them. And now your drawing doesn't have to be perfect, okay? But they would look something like this. So here's number one. Could look something like this. 7.8, 36. And Carl's over here somewhere. Okay, that's 5.9. That's the one possible triangle. The second possible triangle is, this is 36. Martina's 7.8. This is 36. And Carl's actually over here somewhere, 5.9. So given our information, there's actually two possibilities where Carl could be standing. He could be standing right here, or he could be standing right here. And we know, of course, Martina is right there. So the question asked us, what's the distance between them? So here we're going to have two possible answers. Okay? So we'll deal with this top one first. I'll do this one in blue. It's a sine law question, right? Here's our angle side pair. So sine of 36. No, that's the other way. Oh no, sorry, that is right. Sine of 36, because eventually we want to find this distance, but we don't have enough to do that just yet. So sine of 36 over 5.9 equals, we'll call that sine of C for Carl over 7.8. So I calculate, I cross multiply and divide. Sine 36 times 7.8 divided by 5.9. Second function, sine. The first possibility is that Carl is 51, this angle is 51 degrees, which now we can find this one. So 180 minus 51 minus 36. Here this is 93. And now if we know that that's angle 93, now we have 93 and x to go with 36 and 5.9, we can find out how far away Carl is. So I go sine 36 over 5.9 equals, actually I should do that the other way. So I've got the distance on top. 5.9 over sine 36 equals x over sine 93. Again, cross multiply and divide. Sine 93 times 5.9 divided by sine 36. The first possibility is that Carl is 10 meters away from Martina. Okay, that's one possibility. The second possibility is that he's much closer. So again, we do the sine law again. I'll do this one in red. Actually, let's do a different color. Oh. I'll do pink. So again, the process is the same. We got to find this angle C for Carl. So we're going to go sine 36 over 5.9 equals sine C over 7.8. Just like we did here, and we calculated it to be 51 degrees. But now we can tell from our angle that this is not 51 degrees. This has to be an obtuse angle, which is greater than 90. So I'm going to go 180 minus 51 is 129. So this angle right here is 129. If that's 129, 180 minus 129 minus 36 means that this angle up here is 15 degrees. Now we have our angle side pair. We can go 5.9 over sine 36 equals x over sine 15. Cross multiply and divide. 5.9 times sine 15 divided by sine 36 means that Carl is 2.6 meters away. So here, again, we have two possible answers. So when it says what is the distance between Martina and Kyle to the nearest tenth of a meter, you'd have to say they are either 10 meters apart or they are 2.6 meters apart. Now I know this is a long question and there's a lot of steps. There isn't a ton of these on the test, but you do have to know how to do it, okay? Now that brings us to the end of today's lesson. Your assignment in the workbook is on pages 94 to 97. Again, don't feel like you have to do every question, but you're going to want to do enough that you're comfortable with the ambiguous case. And then the test prep is on page 104, numbers 1 to 13. And we'll be having a test on this next class. Thank you. Have a good day.